I used AI as a structural engineer for a year, and some of what it gave me looked perfect but would never work in real life. I tested AI for real workflows. I'm talking about concepts, sizing, layouts, calculations, admin work, and many more. So here's what it actually gets right and where it completely breaks. And here are my top 5 pros and cons. Also, please remember this is based on my personal experience over the past year in real workflows. First one, hand sketches to diagrams. This has been a game changer for me as an engineer. I can take a rough sketch and turn it into a clean, readable diagram in minutes. That means quicker communication externally and internally with professional looking sketches. Again, it does not replace proper modeling, but explaining concepts and ideas is incredibly efficient. For me, it personally feels like it removes the friction from thinking to visualizing, and that's where it adds real value. For those overthinking, this improves the workflow, but doesn't replace engineers. Second, merging, separating of PDF files. Simple, but genuinely useful. Instead of manually organizing, I can just tell AI what I need, split this, merge that, and it's done in seconds. It's not engineering heavy, but it can save a lot of admin time, especially when you've got quite a few PDF files. It's small efficiencies like this that add up over a project. And speaking of PDFs, that brings me to point number 3, that is summarizing PDFs and searching through codebooks. This is a big one. Instead of digging through documents manually, I can ask AI to look up on certain clauses and even ask it to print a screenshot of it. It did do it in certain occasions, and certain occasions it did fail. For large documents, it can save a lot of time. Again, you still need to verify everything, because if it gets something wrong, it won't tell you. Number 4, coding. From catalyst routines to software development, this is where AI really gets powerful. Instead of spending hours in coding and debugging, I can describe what I want and get a starting point instantly, and it massively speeds up workflows. You will still need to understand what the code is doing, but as a productivity tool, it is a big advantage. It basically lowers the barrier to building your own tools. 5, deriving load calculations directly from screenshots. This is surprisingly useful. I can take a screenshot of a wall build-up, for example, in Revit, and have line load extracted instantly in a tabulated format. It also provides you with references as to where it collected the densities and values from. That means no manual retyping and much faster reviewing process. Again, it's great for speed, but you still need to review the units and values. It's a small feature, but for day-to-day work, if used correctly, it could save a lot of time. Now onto the cons. AI often struggles with engineering mathematics, and that's because structural engineering isn't just one formula. It's layers of different code factors, combinations, and conditions. Things like partial safety factors and different clauses from different standards. It just seems to be confused about all of these things. It still might get parts of the calculation right, but overall the answer could be horribly wrong unless you've got your own custom chat model trained heavily to do certain tasks and calculations and not search through the entire Eurocode, for example. Then there could be a possibility of it giving you the right answers. So you can't rely on it for actual design calculations. It is only a rough guide. And that brings me to number 2, false confidence. This is probably the biggest issue. AI often gives answers that look completely correct with clean visuals, proper formatting, and realistic numbers. But underneath all of that, the logic can still be wrong. And if you don't catch it, it's very easy to trust something that shouldn't be trusted. It's not obvious when AI is wrong, and that's what makes it risky. Third, the risk of over-reliance. Because AI is so fast and efficient, it is easy to start depending on it for everything, and that's where the problem starts. You start relying on it, you stop questioning things, and your own judgment takes a backseat. In engineering especially, you'll need to think, check, and verify every step. AI should support your thinking and not replace it. Point number 4, bias and data limitations. AI is only as good as the data has been trained on. So if the data has gaps or biases, the output will reflect that. It might miss newer practices, regional methods, and might give you answers that aren't fully applicable to your situation. So you can't assume it's giving you the complete picture. It reflects existing knowledge and not necessarily the best or the latest solution. Point number 5, security and privacy risks. When you're using AI, especially with real projects, you need to be careful of what you're uploading into it. Drawings, calculations, client information. If the data is sensitive, you shouldn't be feeding that into any random AI tool unless you've got a custom AI in-house built-in chat model. Then it's a different scenario where it explicitly states that data will not be used for training purposes. So while AI is useful, you have to be aware of where your data is going and how it's being used. Convenience shouldn't come at the cost of confidentiality. So overall, AI is incredibly powerful, it's fast, it's useful, and it's changing the way we work. But it doesn't understand, it doesn't verify, and it doesn't take any responsibility. I believe right now, or even in the future, it is still going to be a tool and not a replacement for engineers. Thank you for sticking around till the end of the video, and please let me know your thoughts in the comment below or your personal experience with AI. We'll see you in the next one.